Welcome to BSS Studies. I am Bala. Today I will explain about kinematic equations of motion. Here we already learnt about speed, velocity, acceleration. Here very important, acceleration. Acceleration is nothing but change in velocity per unit time. Okay. So in kinematic equations of motion, there are two conditions. There are two conditions. First condition is body has uniform acceleration. Body has uniform acceleration and body should travel in straight line. So these are the two conditions. So first condition is body should travel uniform acceleration and body should travel in straight line, not any curvy paths, and body should have uniform acceleration. Okay, so these are the first two conditions. So if we see kinematic equations, there are four equations. First one, V is equals to U plus AT. Second one, S equals to UT plus half AT square. Third one, V square minus U square equals to 2AS. Fourth one, ascent means distance for nth second. So ascent equals to U plus A into N minus half. Okay, U plus A into N minus half. So these are the four kinematic equations. First one, V is equals to U plus AT, and second one, S equals to UT plus half AT square, and third one, V square minus U square equals to 2AS, and ascent means distance travel in nth second. Distance traveled in nth second. So ascent equals to U plus A into N minus half. N means we have to substitute time. Given time. Okay. So these are the four equations of kinematic equations of motion. So these are the equations. And the next topic, graphs. Graphs. Here what is graphs? Graph means if any matter or any quantity is represented in Cartesian coordinate system. Here what is this? Cartesian coordinate system. Cartesian coordinate system. So this is the x-axis and this is y-axis. So I am representing this as a 1. I am representing this 1, 2, 3, and in y-axis 1, 2, 3. So if I mark here a point, I will say that the measuring of these 2 points is we have to draw like this straight line. So the measure of this point is x-axis 2 and y-axis 2. So the measuring x and y coordinates is 2 and 2. Okay. So here, before going to like this measures, here in graphs we use Cartesian coordinate system. So this is x-axis and this is y-axis. So this is x coordinate and y coordinate. Sorry, this x coordinate and y coordinate, or x-axis or y-axis. So another axis is there. This is z-axis. Okay. So we don't use the z-axis, only the use of x and y only. Okay. So in this, first one, if I draw like this, it represents the, so if I take this x-axis as distance and this y-axis as time, this line shows that the velocity. If I am taking y-axis as distance and x-axis as time, this slope, I will explain what is slope. This line represents the velocity. Okay, we know already velocity means displacement by time. Okay, so if we see here slope is nothing but y2 minus y1 by x2 minus x1. Here what is y2 and y1? Here I am taking, this is a point in this line. I will draw clearly, see. I am taking, this is a slope, or sorry, line. So I am taking, this is one of the point which is 0, 0, which means the origin of these two axes is this, which means 0, 0. And I am taking 1, 2, and this is 3, and 1, 2, 3, and this is 1, 2, 3, and 4. So this is 4. Here the y2 is 4. First, if we represent like this in an ordered pair, first we have to represent the value of x-axis. So what is the value of x-axis for this point? 3. So 3 comma, and this is the value of this 4. So the point's value of this point is the value of this point is 3 and 4, and the origin, the value of this point is 0, 0. The value of this point is 0, 0, and the value of this point is 3, 4. Very important point here. If I represent the two numbers in a ordered pair, like this, I am taking 4 and 3. First I have to write the x-axis number. Second, I have to write y-axis number. Okay. So this is very important point. So here slope means y2 minus y1 by x2 minus x1. Here, if I find the slope of this graph, the slope means y2. This is y2. Here I am writing, see, x1, y1 means 0, 0. x2, y2 means 3, 4. Okay. So here y2 means this, y1 means this. So 4 minus 0 by x1 means this, x2 means this, x1 means this. 3 minus 0, which means 4 by 3. So the here slope is 4 by 3, which means the velocity of this given ST graph is 4 by 3 meter per second. Okay. So like this we can find the slope. Okay. y2 minus y1 by x2 minus x1. So if I see another example, so if I see here they give the ST graph. I have to find the slope. Here slope means velocity. The slope of this graph means that the velocity we have to find. In the given graph, ST graph, the slope of this ST graph is velocity. Note it. The slope is equals to velocity. Slope is equals to velocity. Okay. So if I see here I have to find the slope. So here y2 means y2 is 5, y1 I am taking here the one of the point p1 and this is one of the point p2. I have to consider 2 points. This is p1 and this is p2. So I have to find the slope of these 2 points, and here x1 and x2 is x1 y1 is 2 comma 3. x1 y1 is 2 comma 3, which means here I am rubbing this point. So if I see here x1 comma y1 equals to 2 comma 3. 2 comma 3. See? Okay. So if I take x2 comma v2, x2 means this. Sorry, this. So 4 comma y2 means this. 5. So if I find here slope y2 minus y1, 5 minus 3 by x2 minus x1, 4 minus 2, which means 2 by 2, which is 1. So here the velocity is 1 meter per second. Okay. So if I take from this point slope, I am rubbing this point, I am taking the slope from this point. The slope will not vary because the slope is constant in a straight line graph. Okay. In a straight line, the slope is constant in every point. Okay. In every given point. So like this we can find the slope of given points. So here another formula is there for doing slope. Slope equals to tan theta. Slope equals to tan theta. If they give the angle between this slope given straight line and this x-axis, the angle between this given straight line and the x-axis, if they give, we can find easily the slope. So if they give 60 degrees, so we can find tan of 60 degrees, which means root 3. Okay, so root 3. We can find the slope root 3. Okay. And if we see another, here I said that the slope of the graph is constant in every point, and if I take like this graph, if I take like this graph, here the slope varies from point to point. See, like this we have to draw the tangents which is perpendicular. Okay, which is perpendicular, we have to draw the tangents. Okay, so like this we have to draw tangents and we have to write the slopes. If we write the slopes vary from this point to this point, or this point to this point, or this point to this point. Okay, so in this graph the slope varies, and in this graph slope is constant. Slope is constant. Okay. And the today topic is completed. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. If you have any doubts, please comment on the comment box. Thank you.